In this style of making objects, there's a lot of encoding work here, and using a macro pattern and creating a tuple of two lists of tuples, and so on. To work towards a nicer syntax, that is a nicer macro for defining constructors like rectangle, we'll make a simplification. Let's assume that all of our methods take just one argument, and furthermore that we always call that argument arg, A-R-G. So the reason for making this assumption, again, is we're moving away from functions and away from looking up things by name, but we want to be able to write things down conveniently, so we'll pick a name for the method argument. So here is our new way of creating an object. We have object with the name of the field equal the initialization of the field. We can have any number of those in parentheses, then a colon, and we can have any number of methods, each declared with the literal word method, the name of the method, the argument always called arg, and then the body of the method. And notice that we're not writing down this. Object will always bind this implicitly for use in the methods. So for example, we'll be able to make a rectangle macro that expands to this object that has W and H fields initialized to those expressions that you pass into the macro. And then we have a area method and an is bigger than method. And in these methods, we can use this, which implicitly refers to the enclosing object of the method. So with this code, then we can make a rectangle and again call its area in is bigger than function. Just to see what this looks like when we put all the code together, we have an untyped Shplait. There is the object macro from the slide. It's using a helper method macro. But then we have the dot macro for the function call form, or the method call form rather, where we pass a single argument in, or the field access form, where we just have an identifier after an expression. And then we have a use of the object macro here to build up the rectangle macro that expands to an object with area and is bigger than methods while it has W and H fields. So if we run this, then we get the area of that rectangle and whether it's bigger than 100. I could call area again down here. I could also get the H field directly, or I could look at R and we would see that in fact it is a tuple of two lists, each with tuples of names and either fields or functions for the methods. We can use these macros for our interpreter of Mo. So I have changed, for example, int v and close v to expand to this object form, and the same for all of our expression forms. Int e, ide, plus e, all of those objects have just an interpret method, whereas values have apply and number methods. So this illustrates how our Mo interpreter could be written in an object-oriented style. Our next step is to make Mo itself object-oriented, independent of how we implement the interpreter. We'll send our interpreter back to its functional style, which is more convenient in Shplait anyway.